Thanks for being with us on the show today, Luke.
Thanks for having me on.
To get things started, do you want to introduce yourself and tell us a little bit about what you do?
Sure. My name's Luke Jennings. I'm VP of R&D at Push Security. A large part of my role has really been sort of looking into new attack techniques and how they apply to the kind of SaaS world and cloud identities, understanding how that's going to change the threat landscape, and then of course like thinking ahead of then how we at Push can help deal with that problem as well.
Yeah, very interesting stuff, and we'll talk about some of your research in a minute, but I'm always interested in people's genesis story. I'm curious, how did you first get interested in computer science, and how did that lead to a career in cybersecurity?
Sure. It goes back to very young, actually. I had some, like when I was 7 or 8 or something, some like little kid's laptop thing, and there was a button on it called Basic, and I couldn't quite understand what it did compared to anything else. But I had a much older brother who just started studying computer science, and he was like, that's a computer language, and he taught me how to do some things on it. Then I got a PC, learned QBasic, then I kind of moved up from there. As a teenager, I learned C++, and then eventually went to university to do computer science. So that was all very computer science, and then the security part came during university, really. And that was, I'd always been very intrigued by the sort of old school 90s hacking stories and all these things, and I didn't really know anything about it. And we didn't really learn about that at university either. It was very computer science focused, but I then was looking for something to do in the summer, and the company I spent most of my career at, MWR, were a tiny startup at the time, and we're looking for like summer interns. I think I was like the 8th person, and I saw a job advert go around of like talking about penetration testing, and it was made to sound very exciting. And I thought that sounds quite cool. So I applied, got the internship, and it just went from there, really. That's the story.
Yeah, that's great. Yeah, and I think the red team is very alluring to most people getting into the field, and then we get into it for a little while and decide that, hey, like the defense side's pretty cool too. So
yeah, definitely, yeah.
So you've been working in cybersecurity since at least 2005. That's almost 20 years. What would you say are the biggest changes you've seen in the field during that time?
Yeah, I guess there's multiple ones. The first thing is just the growth and maybe the professionalism that's gone along with that too. When I first got started, it was like, I feel like it was really starting to take off at that point, but compared to now, like looking back, it was so much smaller and not as professionalized. But I guess other things is like smarter ways of thinking. Like, when it first started, it was very much like lists of vulnerabilities. You have to fix everything. Security is always got to be dealt with. And, I think there's like better ways of managing risk and thinking more holistically about security and probabilities and where sort of remediation efforts are best focused and that sort of thing since. But also everything was all on prevention at the beginning. Detection and response wasn't even really a thing when I was first getting started. That's become, a major part of security and a huge part of the industry now. But otherwise, I think it's just the shifting attacks. I'll probably talk about this more later, but it's like when I started, it was like perimeter security was just kind of starting to die a little bit, and people were finding lots of vulnerabilities in web apps, and then there was like Wi-Fi, and that was the new kind of thing. And then that kind of shifted to like endpoint attacks eventually. And like now, I think, based on what I'm doing here, we're looking at things shifting again. So I think it's like, there's like a generation of focus, and then eventually it moves on to something else. And I feel like I've seen a couple of those in that time. And now we're looking at the next one, really.
Yeah, very interesting. And we'll talk about that next. But I do like how you pointed out previously it was more about wizardry, and now it looks more like engineering, that kind of change we're seeing.
Yeah, that's true too. Yeah.
All right. So I asked you on the show today because I was really interested in some of the work you're doing around what you're calling the SaaS Cyber Kill Chain, which is basically an evolution of what the traditional kill chain most of our listeners probably are familiar with. In the talk I watched you gave on the SaaS Cyber Kill Chain, you classify companies into 3 buckets: classic, hybrid, and cloud native. Can you quickly define each of those for us?
Sure. So I'd say like classic really is kind of your internal network, everything being on-prem, in-house dev teams making custom applications. That type of situation, everything office based as well, maybe VPNs. It's kind of your classic organization, what most people would think of if you look back. Whereas cloud native would be your sort of newer companies that have started or been founded recently enough that not having any infrastructure has been a valid option when you're starting out from scratch. So maybe you have offices, maybe you don't. But even if you have offices, they've probably just got internet connections, and beyond that, it's just a fleet of laptops, maybe with some sort of device control and remote management, and then everything's just in the cloud. It's just a different SaaS app to solve different problems, and each user, they might use 20, 30, 40 SaaS apps, in some cases more, maybe 100, for really heavy users of different things. And then hybrid, I think it's just that the middle ground. Normally, I'd say it's people they're in that transition phase where they're gradually adopting more SaaS solutions, and then maybe they're also starting to kind of decommission some of the on-prem solutions they have, and maybe removing different parts of their legacy parts of their network. And it's kind of process. I mean, to be honest, there probably aren't that many truly classic organizations left. I think even, like all the biggest enterprises are really in somewhere on that hybrid spectrum now. So in a way, there's two. There's hybrid and there's cloud native. But yeah, that's what they are.
Okay, interesting. Thanks for that definition. So the Cyber Kill Chain has a lot of different phases, and I don't think the SaaS Cyber Kill Chain maps one-to-one, or at least you didn't cover all of those in your talk. I'm just going to go through the ones that you covered in your talk. And the first one was a recon phase. In a classic environment, it would be stuff like pings and port scanning. What does this look like in the SaaS world?
Yeah, okay. So, when you start out with recon, I think in this world now, you're no longer talking about IPs and domains and open ports for services, and therefore you're not looking at the same sort of scanning techniques that relate to those. I think now, if you're mapping the attack surface of an organization that's cloud native, or you're looking at the hybrid components for a hybrid one, it's much more about which SaaS services are in use by the organization, and like where are the login portals for those, what are the tenants that are involved, who are the users, what are the cloud identities that are in place that allow access to those things, what SSO or IDPs do they have in place to manage kind of centralized logins, and which ones are unique logins to individual apps. And so it's building that out. It's understanding exactly what their attack surface is from that perspective, rather than your traditional IP space and ports.
All right. And so there's SAML enumeration and slug tenant enumeration. Can you quickly sort of go through those with us?
So yeah, there are a couple of examples of it. So like often organizations will want to link SaaS apps that they've kind of officially adopted to an SSO endpoint, for better security and manageability. That's normally, not always, but it's often using SAML, for example. But that often gives you the ability to tell that a SaaS app is in use by a particular organization, because if you find their particular login tenant, or you try to log in with a particular email domain that's their email domain, it'll have been configured to redirect to their SSO portal. Mm-hmm. So you then kind of, through the SAML process, can identify, Jira has been set up to authenticate against this company's SSO, so they must be a user, and this is how their users must access it. So that's one aspect. Slug tenant enumeration is like another similar thing, but when you have to create a named tenant for a SaaS app. Not every SaaS app acts that way, but sometimes when you set up a new account for an organization, you'll need to give it a name, and sometimes that will end up the subdomain for the SaaS app. Sometimes it will be in the path, depends how they choose to implement it. But often it almost becomes a bit like DNS brute forcing or enumeration. If you try different common names for a company, for a SaaS app, when you're trying to register a new one or do it, you'll find instances of ones that already exist or are taken, and that can then lead you to legitimate examples in use by an organization.
Mm-hmm. Yeah, that's interesting. And I know we internally use some apps like that where our company name is the subdomain of the service that we're using. So that's an interesting way to kind of discover what internal tools a company is using. Another one that was looked at was initial access. Seems like a lot of paths with this one. How does this manifest in the SaaS world?
Sure. So I think, this is a bit of a blended one. Like, I think there's some very classic techniques that everyone's super familiar with that just have slightly new flavors in this world. And then there's some pretty new techniques as well. So if I give some examples, I mean, things like credential stuffing, that's effectively another form of password brute forcing, or, just password guessing, or using existing known credentials. It's been around forever. I think the difference is here, it used to be that to target an organization, if you were trying weak passwords or known compromised creds, you had one or two places to try them, like a VPN endpoint or webmail endpoint or something like that from the outside. But now you might have hundreds of possible SaaS apps that they could be valid for. And even if, there's a well-managed SSO identity that doesn't have weak passwords or is better protected with MFA that controls access to many of the SaaS apps, there may be other ones that users have signed up to that don't support SSO, or that users have self-signed up to, so IT's not been involved, and maybe they used weak or compromised credentials in those examples. Maybe there's no MFA on those ones. Yeah. So you can kind of shotgun across so many apps and then see what drops out. So it's actually, in a way, it's just taken an old technique, but it's kind of increased the vulnerability there because it just goes across so many other potential platforms. Then if you get to the sort of phishing side, again, you've got slightly new variations of it. You've got things like consent phishing, where rather than phishing for credentials or trying to get someone to run some malicious code, you're looking for them to grant OAuth permissions to you. And then the interesting thing with that is you're generally sending people legitimate URLs that point to like Microsoft or Google. And it doesn't matter whether they're using passwords and strong MFA or anything, because you're not compromising the authentication process. You're asking them to literally delegate access to their account to you. Mm-hmm. So consent phishing is an interesting one there, because it completely bypasses strong authentication controls. It's just a different mechanism. And then you get, if someone falls for it, you get effectively permanent access to whatever they delegated to you. And it doesn't matter if they change their password or their MFA in future, because it's unrelated to that. So I think, that's another interesting aspect of phishing. And then I think the delivery vectors is the other one. I mean, phishing has been primarily email based for so long. Even once instant messenger platforms became more normal, I think it's stayed email based for a long time, because that's like the one universal constant for communicating between companies. Whereas, if you use Slack or use Teams, there's not a universal transport mechanism there. And to begin with, they were purely internally focused anyway. So they might be valid options for internal phishing, but when you're trying to get your initial access thing, they weren't an option. But obviously, because instant messenger applications are so useful, we've since seen external vectors into them with like Slack Connect and Teams external access. And now, people are less familiar with those as phishing angles. Even phishing training is more focused on email. They're new vectors to bring things in. There's new tricks you can play via Teams and Slack and so forth. So it's just a good new delivery vector in this world. So that's the kind of the more traditional ones. But if you move on to like some of the more, the newer techniques in this space, we've got things like poison tenants and SAML jacking. Like a poison tenant is like the idea of convincing someone to start using a tenant on a legitimate SaaS application that you as an attacker control, and then benefit from that. So like, if it's going to be valid URLs and so forth, it's also a legitimate SaaS app. But it can be as simple as like using user invite functionality that may trigger legitimate emails from a legitimate SaaS app to go out to the users you're targeting, say, oh, you've been invited to join the new tenant for this. And if you can get people on board to your app there at a particular stage, then you've got admin control of that tenant. You may have access to all the data you want through that if they begin using it. Or it may be something that's simple, but you can use it as a leverage point to launch further attacks. So like it doesn't matter what data is going into it, but it becomes like a watering hole for then launching further things. And it's a tricky one because certain instances of this are unrealistic. Like if you're targeting a large organization and you want to get them onto your Slack tenant, like it's probably not going to happen. You're talking about a whole organization thing that's probably been set up from the beginning. Yep. But if you're talking about smaller solutions and targeting individual teams where they might be looking at those solutions already, maybe a new smaller marketing, the SaaS app, and that the marketing team are already looking at something, and you can get in there early and then try and set up a tenant and start inviting people and getting people on it. It becomes a little bit more realistic.
Sending them Canva invites or something like that.
Yeah. Something like that. So it could be that, they use that app then and they put information in there that's of use to you, or it could be that it's a watering hole thing. So like SAML jacking, I'll explain that now, and then I'll quickly say how that often combines nicely with poison tenants. But SAML jacking was me thinking about, well, is there a way of like abusing SAML for offensive purposes, basically? So SAML itself is a great thing, enables you to do SSO with lots of applications. It's a good thing to be doing. But in order to configure it on most SaaS apps, they'll allow you to effectively create a redirect to a server you control during the login process, because that's effectively how it kind of works. And depending on how that's been implemented, that means you can set up a tenant, like a poison tenant, for example, and you can configure a SAML process that means it directs to a phishing page you control, and that will happen during the login process. So then when it comes to like the phishing process itself, rather than sending someone to your phishing domain that you've set up, you'll be sending them to a legitimate SaaS login page that will then redirect to your malicious page. It might do it immediately, or it might show the login button, and then when they click login via SSO, it then redirects. But in terms of when people are normally assessing a domain, like looking at it and thinking, is this a suspicious link or whatever, it's normally that first point when they receive it, and the link you're going to be sending them is a perfectly legitimate SaaS domain vendor link. So it's like, if you catch them at that point, they've then got to realize that it redirects afterwards, re-examine the link, and then realize it's malicious. It's just obviously much less likely someone's going to catch that. And so, like combining that with a poison tenant is a brilliant one, because you get people on your tenant, and then you could even turn that into a watering hole attack, because then later you can, once you've got a number of users on it, you can change the configuration to SAMLjack at a certain point, and next time they come back to log in, they get phished, and you haven't even had to send them a link at that point. They're already using the app. So you take it to another level of sneakiness. And actually, like one other thing I spoke about recently, that this is almost, it's related to SAML jacking, and so I called it octajacking. But also I can't take full credit, because I got the idea for this from Adam Chester for some great research he did into Okta. But Okta gives you the ability to like link to Active Directory. So you can kind of synchronize between Okta and AD, and you can delegate certain Okta logins to Active Directory. Obviously very useful enterprise functionality, and great for hybrid orgs that are in that process of migrating between older Active Directory instances and something newer. But in order to do that, that means Okta will take the credentials someone gives them when they're trying to log in and send it to your domain controller through an agent that you can install and configure. But that means as an attacker, you can set up a malicious Okta tenant, configure it in that, in a way to then send you credentials, and then you can literally send an actual Okta domain to a user. It won't, and you don't even have to have the redirect at that point. It won't redirect to a phishing page you control. It will still be a legitimate Okta domain. They enter the credentials, hit login, and Okta will send that password to you as an attacker. So that gets even sneakier for the phishing page, because at that point you're like, there's no part where you get the ability to spot it's a malicious link, other than it being like a different Okta tenant, not the Okta tenant that your organization might use. But in terms of like domains and URLs, it's all fully on an Okta domain. So that's like a related one that's kind of quite specific to Okta. None of these things are vulnerabilities. They're just abusing features. Like a lot of security issues end up being, it's like someone makes a feature, often it might be a security feature itself, and then you think as an attacker, how do I exploit that? How do I abuse that in some way? And that's what some of these attacks are.
Yeah, and like that Okta attack, I can see that being more and more effective the larger the organization is, because there's sort of less knowledge throughout the employees about what's happening at an operational level.
Sure. Yeah. No, probably will be. Yeah.
So in the SaaS world, persistence is a bit of a concept as well, isn't it? The goal here would be to maintain access to a particular app.
Yes. I mean, to be honest, if anything, persistence is one of the phases that scares me the most in this world. But yeah, I mean, we're talking about, rather than maintaining access to an endpoint, like with run keys or whatever, and there's a million different run keys, for Windows, for example. We're talking about maintaining access to individual SaaS apps or cloud identities that relate to them, so that once you've compromised one in the first place, password changes and so forth are not going to kick you out.
Yeah, and there's some interesting techniques that are used. So from your talk, I got link sharing, API keys, ghost logins, OAuth integrations, evil twin integrations. I found super fascinating. Do you maybe want to go through a couple of those?
Sure, I will do. I mean, some of these things are super simple. So with API keys, it's just the concept that a lot of SaaS apps out there have APIs, and not necessarily admin-only ones. There'll be user-level ones. So an ordinary user can just click Create API Key and use an API for their account. So if you gain temporary access as a user to a SaaS app, as an attacker, create an API key. Most users don't use those APIs, will probably never notice. Then you've got your backdoor into that account. Ghost logins is a similar one. So that's the sort of term I've coined for it, but there's a few different things that fit within it. But it generally relates to the ability to set up multiple ways of authenticating to a SaaS account. So maybe you normally access it with an SSO account, like via Google or Okta or something, and it's been configured by your IT like that. But often SaaS apps have the ability to still go and set a local password, or they might have like a secondary email login that you can add, or it might have the ability to connect social accounts like Facebook, Google, Microsoft, whatever, Twitter. And so you can go and set up those additional things, and they just become, it means that it's adding like another identity that can be used to access the same account. And you then decouple it from the SSO mechanism. So again, like someone changes their password after that, doesn't matter. You've set up persistence. Mm-hmm. Link sharing is probably even the simplest, but this is an interesting one because it decouples from the user entirely. The idea is, there's a lot of apps out there have the functionality to share something with external users that don't necessarily have access to your like organization level account. The simplest thing would just be like, you've got a Google Drive file or a OneDrive file, and you want to send it to someone outside your organization. You can create a sharing link so that if they, that's controlled, say just by knowledge of the URL with, a randomized, unguessable component, and you send it to someone, they can look at that. As an attacker, if you just go and automate the creation of sharing links for like every file that the user has access to and that sort of thing, then you then have ways of getting back to all that data in future without needing the account at all. Generally, like unless it's their own personal files, even if that account gets fully deleted, like the user leaves, the employee leaves an organization, you still might have a way back in there. And I mean, things like OneDrive and Google Drive are the obvious ways of doing it. And at least in the interface, it might be more common for someone to spot if suddenly every single file seems to be shared. But you can just share root folders and it inherits to everything. So you don't have to do it in many places. But actually, they're not the only apps. There's, like lots of apps have similar functionality, like ticket management platforms that have ways to share tickets externally, wikis that have ways of doing it. And many of them, it's really not obvious that stuff's been shared unless you're actually looking for it. Like you'll never notice it by accident. So there's a lot of places where that can be done. So that's another one that's very interesting. I think where it gets slightly more technical is with OAuth integrations. So they're designed very much for sharing data between applications. But yeah, like you can use OAuth to delegate access to certain components with an app. And then that means you gain the ability to continue making use of those permissions without actually having to control the underlying account that you granted them with in the first place. So like OAuth is, like I mentioned it before with regard to consent phishing, and I think most people normally think of the offensive use of OAuth with consent phishing, but it's actually just as important with persistence, because when you already control the account, you can just go and grant access to things yourself. You don't need to trick a user into clicking that button. You just go and grant everything you want and then disappear, and then you maintain that access. And then when it gets really sneaky is the evil twin integrations side, because that's an idea of, if you use legitimate SaaS platforms that use OAuth to gain access to things, if you use an application that's already in use by the organization, and especially already in use by the user you're targeting, it becomes very hard to see that there's like a second connection there, because with OAuth, like generally a SaaS vendor will have one OAuth app. So if I wanted to, delegate access to Zapier or something, and someone's already using it, it'll already be there. So you won't see a new app appear or a new permission grant appear for the user if it's already in use. But ultimately, I could connect up my own malicious tenant I've created as an attacker separate to the legitimate one. It becomes very hard as a defender to see that there's two different Zapier tenants accessing information. So that's, like evil twin integrations are a pretty interesting one there. It gets very difficult to spot what's going on.
And then if you have the user from a Zapier integration and you create this evil twin integration, you're then able to access the same resources they've already authenticated in the first Zapier integration. And like you said, it would be very difficult for defenders to see that in the telemetry passing through their org.
Yeah. So they wouldn't have new app permission grants or anything to review. So you'd just start seeing Zapier do new things, but from your perspective, from an existing integration, really. Only the new things it's doing would be malicious in this case, rather than the legitimate ones from before.
Mm-hmm. Yeah, and I think that kind of leads into this, which is during your talk, you mentioned execution, and I really thought about maybe that as code running on my machine. It's hard to think about how it makes sense with SaaS applications, assuming we're excluding cloud services like AWS, Azure, and GCP. Can you tell us a little bit about what execution looks like under this model?
Yeah, so I mean, this was one of the phases that I thought maybe didn't exist in the SaaS world, first of all, like this and command and control. I initially thought didn't translate, but then the more I looked into it, I realized that there was a new paradigm of execution, and that was automation platforms, no code and low code. So you're right. I mean, you could say it applies to AWS and so forth too, with like serverless things, but it's such a small component of the overall SaaS picture. It's quite specific. Realistically, most of SaaS is based around people not executing code, and SaaS platforms not allowing you to run custom code. It's just features that you use. So that's why I initially thought maybe this phase doesn't exist anymore. It's not about getting control of the IP and getting code running anymore. But automation platforms are, I think, the closest equivalent in the SaaS world. So like Zapier is an example of them, but there's lots of them, If This Then That, Make.com, Microsoft Power Automate. There's quite a few, and really they're mostly based around enabling you to connect lots of different SaaS apps together and customize what happens. And so some of them enable you to actually write some type of actual code in some sort of scripting language, but some of them are pure like drag and drop, like aimed at people that are not programmers, but enabling them to do or create custom activity. And that's the equivalent here, because I think then you can do almost anything you might want to do through these platforms. It's customizable enough that it's like code execution in that way. So it could be things like, if you use Zapier as an example, you connect it to someone's OneDrive and to their Outlook or something, and then you could set up different automations to do common malicious tasks there. You could say, I just want to siphon off every new file they create. So you could most of them are based on like event triggers and actions. So you could say, okay, every time there's a new file created, or there's a change to an existing file in OneDrive, download that file and send it to my attacker-controlled Dropbox over here. You could do the same thing with mail. Every time they receive a new Outlook message, forward it to my Gmail address here, a bit like you might do with malicious mail rules sometimes, but it's another way of doing the same thing. Or they receive a security alert that might be related to other things I'm doing, delete it before they see it. It's all those kind of things. And the interesting thing is, once you've set up the connections, because they mostly use OAuth themselves, you don't even have to build everything ahead of time. Like, you could build your automations to do some of those tasks I've just said ahead of time if you'd like, but as long as the connections are still in place, even if the user then goes and changes their password, resets their MFA, security teams involved, they think they've got you out. It's not just that the things you've already set up will continue to siphon data, but those connections in Zapier, you can go and create new automations and say, use this existing OAuth connection. So it's like you almost not just have your existing code deployed and doing things, but you can continue to create new automations in future, even after you've lost access to the account. So they're pretty damn powerful. I looked at a few different examples and spoke about some of those, but interestingly enough, this is definitely to some extent happening in the real world as well. Because I noticed recently one of the posts that went out from Microsoft about like Scattered Spider, Octotempest, that sort of group. They've been doing a lot in the SaaS space, but there was like a note in there of them using Fivetran, which is similar. It's like a data movement focused platform, but using that to steal, like, harvest databases via API connectors, like steal Salesforce databases and Zendesk databases and so forth. So it almost seems like this stuff's actually happening or real threat actors are using this as well at the moment.
Yeah, it's a little bit terrifying. Lateral movement's another one of the kill chain steps I didn't really expect to come up when talking about SaaS apps, but you gave several examples. And I guess the obvious and most dangerous one you pointed out was having your email compromised, because the SSO via email accounts can be the gateway to everything, sort of the hub and spoke model. Can you briefly talk about that and some of the other ways that threat actors are able to perform lateral movement?
Sure, yeah. So, with all of these phases, the first thing I had to do was think, like, what does this mean as a phase in this world? Does it have an equivalent? And I think, in the older world, lateral movement is very much infrastructure orientated. You're thinking of, okay, I compromise this endpoint, now I want to move to this other endpoint or this other server, or I've compromised this server and I want to get from that to a different server. Maybe in some cases talking about moving from accounts to accounts, but it's still quite infrastructure orientated. In the SaaS world, we're really talking about, it's no longer machine to machine. It's like cloud identity A to cloud identity B, or it's like SaaS app A to SaaS app B. That's what we're talking about. So, it can be, as you say, things like email. Like, email's a classic one for compromising a lot of things in one go. So if you gain access to a user's email, either through compromising like a core SSO account they use, or maybe they've delegated access to their email to a different SaaS application that's not as well protected, like a marketing platform that hooks in with their email or something and needs to send things on their behalf. And then you compromise their account on that SaaS platform, and that gives you a view into their email. Or then you can trigger off just simple things like password reset and account recovery mechanisms for lots of other SaaS apps. And then you're sort of moving to different SaaS apps but under their same kind of identity. Or like some SaaS apps have passwordless logins anyway. So you do a login, and rather than have a password, they'll send you like a one-time password code. So you've got a lot of options for that kind of thing to just like move out and compromise lots of apps in one go. And I've kind of implicitly spoken about another aspect here with that example, but there's also the ability to like abuse existing integrations. So I kind of covered two in one there, talking about compromising like another SaaS application that's already been connected using OAuth to some other resource. That's another way. So, you compromise an account on a lesser protected SaaS app. Someone's already connected that in some way to other platforms or other accounts. And and then you can use that to pivot. So yeah, it could be that they signed up and used a weak password that wasn't via SSO, and you compromise it that way, and then you find that they've connected OneDrive to that account, for example, and then you've got a way to browse their files as well. It could be even they started out with a personal account on there, and then later were using it, wanted to use it for something to do with work, needed to export things to their work OneDrive. So they they connected it to the OneDrive, and then you've got sort of blurring of personal and corporate identities at that point too. So that can be one. Another really simple one is just things like link backdooring. Like we can catch people out with phishing attacks even when we're going via the very known and like delivery mechanisms like email. But if you start subtly backdooring links on trusted platforms that you've gained access to, especially where in the SaaS world now, there's often links in lots of different apps, and there aren't always like many security mechanisms around what links are allowed. It could be a ticketing system, could be a wiki. I mean, wikis are great ones because often people have very wide-ranging edit access to wikis. You could do a shotgun approach. You've gained one account of one access, and then you go and just find every link that you've got write access to and subtly backdooring it so that every time someone clicks it in future, it kind of goes through your attacker in the middle proxy to try and capture credentials. Or you could be really targeted. You could say, I need to get access into like the AWS, and only certain core devs have that. And then you find the wiki page of like how to set up the AWS environment for new joiners or whatever. And you think, I don't know when the next new joiner is, but I'm going to go and very subtly compromise a link in that one special bit now and sit back and wait. And the next time someone joins the development team and goes through that, I hopefully gain access to AWS. So you can do it in a few different ways. But yeah, the general concept is figuring out ways to move between apps or between different cloud identities.
Mm-hmm. Yeah, so many new attack paths in this world. It's kind of mind-boggling. And I imagine one of the biggest challenges with creating a defensive posture across a cloud-native company is that the way things work differently in every different SaaS application. I imagine like regularly scheduled audits and things are probably part of a posture here. Do you have any advice on how vendors can think about this stuff to create good security postures?
Sure. I mean, I have some advice, but it's so early, it's hard to give lots of advice. So I think at the point, even though I've been doing a lot of research in this space, I'm at the point where I feel like I've opened a can of worms a bit, peered into Pandora's box a little, and I've got some ideas, but I certainly don't have all the answers. But I think, the moment, like we're going to start seeing more and more shifts of attacks to this space. And I think the first bit of advice is like, don't put off thinking about this. Mm-hmm. Like everyone needs to be thinking about this now. I think we're going to start seeing quite a rapid shift in this space. The other point is, for hybrid organizations, whatever SaaS you think you have, like if you've not really gone and looked into it, it will be so much more than you expect, or at least that's my experience from where I've seen this in organizations at the moment. So if you're thinking, oh yeah, but we don't use it too much yet, it's not a big problem yet, you're probably wrong about that as well. So I think really it starts simple. I mean, I don't have advice of how to like deal with every single subtle attack technique that I've like mentioned on this call yet. I mean, to some extent, I'm just exploring these and opening the conversation and raising awareness on it. But the first point is literally just to start finding out where all your cloud identities are, which SaaS apps are in use, who uses them, how do they access them. It's starting with the basics and working from there. Like I think everyone needs to be thinking about this now, not putting it off to maybe next year or whatever. And yeah, just starting that first simple process of gaining visibility and working from there. Beyond that, I think then, if you suddenly find out in an organization you've got like this big new app in use you didn't know about before, normally you might want to kick off a security review and do quite a lot of detailed analysis at that point. I think in this case, often the scale is so much that you won't be able to do that either. So like you'll want to do that, and then you'll look into things and you'll find 100 apps you didn't know about. And then you don't have the time, you can't do that detailed analysis you wanted times 100. So it's then figuring out prioritization. It's like, what does each app do? What data are they likely to store? It's like it's taking the breadth first approach, and then trying to figure out what are the ones you need to put a bit more effort into and pay closer attention to, and really prioritize from there.
And you're doing some work that I think people can follow along with. Can you tell us about the SaaS attack matrix?
Sure, yeah. So like when I started looking into this, from an attack perspective, I did a little bit of a breadth first approach too. Gradually added new techniques as I found them and documented them. Then I started putting them into the phases. And the more I built up, eventually I thought, I was doing it purely for internal purposes, for push to begin with. But then eventually I was like, this is just really useful information that should be available. So I created a GitHub repo for it, just made it an open source project, and I've been trying to document all these techniques along with a few examples of each of them. So the SaaS attack matrix is essentially, a list of all the techniques that I've kind of put into this space, mapped a bit like the MITRE attack framework into different kill chain phases, with then a sort of basic write-up of each. And for everyone, I've got at least one example of like a SaaS app it applies to, just to give a practical example too. But in many cases, some of them will apply to 50% of all SaaS apps or 25% of SaaS apps, whatever. But I just try to make sure there's at least some practical examples in there. So really, it was a case of just putting that out there to raise awareness. Because then I figured, it should be useful to both red and blue teams. If a red team is used to attacking more traditional organizations, and they've got lots of experience doing your endpoint compromises and lateral movement that way, and then one day they hit a fully cloud native organization for the first time, where do you start when you first do these things? Well, it's a good place to look at, to start from, to get ideas and think, what of these could we use? And similarly for blue teams, if you're like first thinking about this problem and trying to think what are the problems like, and what are we most worried about, then it's just a good place to start from and work from there.
Mm-hmm. Yeah, it's really fascinating research, and I'll make sure that I link the SaaS attack matrix in the show notes. Really appreciate you doing this for the community. It's awesome.
Thank you.
So this is the final one I have for you. It's the one I ask of everybody who comes on the show. It can be as wide or as narrow as you want. Do you have any predictions for the future of cybersecurity?
I've probably partly already said it through this, but I think for me, it's that we're at a turning point now in the way attacks are going to be conducted. If like looking back to the past, there was that point when we shifted from perimeter attacks to like web app attacks, and then there was a point when things got better there, and people eventually one day shifted to endpoint attacks. And then there's a cat and mouse sort of game, and everyone has to, catch up. And then that makes a huge knock-on effect on like the defensive industry. It's like when endpoint attacks first started becoming normal, that kind of created the whole entire EDR industry eventually, for example. I think at this point in time, we're at that like really early point where people were first starting to explore endpoint attacks, but it wasn't the norm yet. I think we're at that point now in this SaaS space where it may rapidly become the norm, because the endpoint compromise space has been common for a long time now. There's a lot better controls in place. People are getting better and better at defending against them. That's the security push angle, as in it's getting a harder target. But then the technological angle is that we've got a massive technology paradigm shift in organizations of moving away from having internal networks and so forth. So like a lot of the things that people are attacking are gradually ceasing to exist in newer companies. Mm-hmm. And so in 5 years' time, there might be a huge percentage of companies that don't have any infrastructure to attack anyway. So yeah, I think we're right at the beginning of that point, where that switch happened. And yeah, so I feel like 5 years' time, certainly 10 years' time, we'll be looking back, and this will be the very beginning of that. So that's, I guess, my main prediction. What the next one is after that, when in 10 years' time I'm sitting here saying, referring to the SaaS attacks and cloud identities attacks as traditional attacks, that bit, I have no idea. That's far too far ahead for my crystal ball. But
Yeah. Change is the only constant, right?
Yeah.
Yeah. Awesome. Well, thanks so much for being on the show with us, Luke. This was a really great and educational conversation. I think it's going to provide tons of value to our listeners. So thank you so much.
Thank you for having me on.